Welcome to Ascend, the unified data engineering platform for building and running autonomous pipelines. This video will provide you with an overview of how to transform your data with Scala. Although we'll be going through a Scala example in this video, the same principles apply for writing transforms in Java or any JVM-based language. Our example dataset is the GitHub archive of events, including when developers have pushed commits to open source repositories. The goal will be to extract the commits out of the JSON payload into a clean table of one commit per row. Let's take a look at the Scala code. The Ascend interface is a class with a function called transform that takes two arguments. The first is a Spark session, and the second is inputs, which is a Scala seek of data frames. The function simply needs to return another data frame. Notice in Ascend, you're not dealing with any reading or writing from blob stores or any of the side effect parts of your transformation. In this case, we'll filter down the rows just for the push events, parse some of the JSON columns using the schemas, and explode out the commits array so that we can get one row per individual commit. We'll select a couple of the columns that we want and drop the rest. Then we just need to package up this code into a jar and upload it to our preferred cloud provider. In this case, we're using Amazon's S3. Back in the Ascend platform, we're now ready to wire everything up. We'll create a new transform, and we'll name it extract commits. We'll pick Scala for the type, and we need to pick our partitioning strategy, which will determine which parts of the dataset are selected as part of the input data frames. We'll then input the entry point class name, and allowing the user to specify this class name means that you can use the same jar for multiple different transformations. The last part of our required configuration is just where we uploaded the jar to. For more advanced use cases, you can customize the Spark configuration, including which Spark runtime to use. For this example, we can stick with the latest version of Spark and Scala. Upon creating the component, Ascend automatically detects that processing is necessary, dynamically configures the Spark jobs, and scales up as necessary, all while monitoring the different Spark jobs for success and retrying any failures. With Scala transformations, Ascend developers have a rich toolbox to model and wrangle any data complexities. As always, we can't wait to see what you build next.